conserve. So that's the idea. All right, let's switch back. I'm gonna switch back, and then I'm gonna rebuild this concept up. Now that we're talking about the potential and potential energy of the charges. Okay, let's talk about the potential, the idea of potential. All right, so the idea of potential, I'm gonna go back to the engineer's definition of it. You got this capacitor or the electron gun. One region is going to be positive charge, which is this. The second region is going to be negative charge. And then you have this electric field, a constant electric field in this region, pointing from the positive charge region towards the negative charge region. And notice that these charges, these regions are actually separated for a distance of r. So the r is going to represent the separation distance between these two regions. Okay. Mathematically, the potential can be written in terms of the strength of the electric field between two opposite charge regions times separation distance. All right, this is known as potential or voltage, or potential difference or voltage difference. Okay, so mathematically, this is the way it's represented. The question is, what does it mean? All right, when you guys are reading a textbook, they will give you a textbook definition. And when you are looking at it, it doesn't really mean anything outside of the abstraction of the mathematical description of it. All right, so we have to kind of dig into that and figure out the meaning of it. All right, so potential difference or potential difference or potential, they mean the same thing. So let's just put this down. So this means voltage or potential. Okay, let me just, this is over. Voltage the same as the potential. All right, I'm just going to put it in. It can mean voltage, or you will hear voltage difference. Or the voltage also means potential or potential difference. They mean the same thing. All right, so the proper unit is going to be V. V means it's going to be volts. All right, so this is the way it is expressed. We know what E is. Let's write it down one more time. It's the electric field. It's the magnitude of the electric field, the strength of the electric field. So it's going to be expressed in terms of newtons per coulomb. R here is the separation distance between two opposite charge regions. All right, so this represents the distance between two opposite charge regions. All right, so it's going to be expressed in terms of meters. All right, now let's talk about, now that we talked about the book definition of it, let's talk about the meaning of what we're looking at. Guys, potential or voltage represents the amount of energy stored within this region. All right, so within the space in between two opposite charge regions. So what does this represent? It represents the amount of energy stored within the space between two opposite charge regions. So you're dealing with the energy stored within this region. That's what it means. So the energy is going to be stored inside the electric field. All right, we will clear this up. This is the first attempt. So the energy is going to be stored inside the conservative force field. All right, so what does that represent? It represents the amount of energy stored within the space between two opposite charge regions inside the electric field. All right, so this is your electric field. Obviously, the larger the separation is, the more energy is going to be stored in it. Does that make sense? So the potential or voltage represents the amount of energy stored between two opposite charge regions within the electric field. So what that means is, stronger the electric field is, and that's what the engineer was talking about. Stronger the electric field is, larger the voltage difference. All right, which means that the more energy is going to be stored within that region, more energy is going to be stored within that field. That's what it means. So voltage or potential represents the amount of energy stored within that field. So how do you energize a charge, guys? It's really straightforward. How do you energize a charge? I don't know. I'm just going to drop a charge into that region. That's it. So what happens? As soon as you drop a charge in that region, charge becomes energized. When you place a charge into a region that stores energy, that energy gets transferred to the charge. So this region is already energized. So what I do is, this region is already energized. So this represents the amount of energy contained or stored within that region inside the electric field. And then as soon as I drop a charge here, now this charge has potential energy. So which means that the charge becomes energized. All right, now that charge has potential energy. All right, so as soon as I place a charge here into this region, what happens now? This charge is going to have potential energy. All right, I'm going to change notation here. I'm going to use the letter U, and the letter U is going to represent potential energy. All right. All right. So V, in this case, the voltage potential, represents the amount of energy stored within this region. U represents the amount of energy stored within the charge. So how do you transfer the energy from field to the charge? How do you do that? So how does the energy get transferred from field to the charge? It's easy. The voltage, the amount of energy stored within that region, the only thing you have to do is just drop a charge in it. As soon as you drop a charge in it, what happens? Now the charge has potential energy. You know that the electrostatic force field is a conserved force field, right? So what happens to the potential energy of the charge when you actually release the charge? You drop the charge here, now it's got potential energy. And then you let the charge go. What happens to the potential energy? It turns into kinetic energy. Very good. So, all right, so mechanical energy, you know, the kinetic energy plus the potential energy is the mechanical energy. All right, let me put N here. Okay, so I don't want you to confuse these two. This one is the electric field. This one is going to be the energy, mechanical energy. All right. So, and this is the mechanical energy because we're dealing with the conservative force field. All right, so that's the mechanical energy. Mechanical energy is going to be conserved, and you know this is going to be constant. It's going to be constant because the electrostatic force is a conservative force. Mechanical energy is going to be constant. So you energize the charge. So the charge gets energized, and the charge is energized. All right, so you drop a charge into this region. Now the charge has potential energy. You release the charge. So the electrostatic force field is acting on it. So the charge is going to accelerate in this direction. So electric field acting on the charge is going to cause a force on it. So it's going to accelerate in this direction, right? So it's going to accelerate in that direction. So as soon as you release the charge, what's going to happen is the potential energy is going to go down, the kinetic energy is going to go up because the mechanical energy is going to remain constant. All right, so everything that we discussed yesterday regarding gravity is also true here. Holds true here. Okay, before we take a break, let's just go back and then summarize this information. Okay, I'm afraid to move this around. All right, let's get out of here. All right, just go to lecture review. Okay, so we're getting the lecture review. What's gravitational potential energy? All right, so let's use an analogy. So it's going to be mg times the height. Okay, so gravitational potential energy, most of you guys usually think of physics in terms of these formulas. It's not, guys, just get the concept. All right, so this is the amount of energy which is stored in an object by the amount of work that you do against gravity by lifting something up. That's what it means. So you're lifting something up against gravity, all right, through this distance. So you're applying a force on. All right, so you apply a force on the y direction, and then you lift it up. The amount of work that you do in lifting something up is going to go into the potential energy of that object, which means that you're energizing the object. Okay, so what's gravitational potential? I don't know, so I'm just going to move forward. Okay, we don't know yet, but we will get back to it shortly. All right, so what's electrical potential? So the electrical potential in this case is going to represent the amount of energy stored within the electric field between two opposite charge regions. All right, so this represents the amount of electric field which is stored between two opposite charge regions. One region is going to be positive charge, the other region is negative charge. This is your R. All right, so the electric field is pointing in this direction. So this represents the amount of energy stored inside the electric field, the conservative force field. So what is potential energy? In this case, potential energy is the amount of energy stored in the charge. So the potential energy in this case, you energize the charge by placing the charge into this region. Now it's got potential energy. So this represents the stored energy. Electrical potential energy is stored energy. So the next question is a valid one. So what's the difference between the electrical potential energy and the electrical potential voltage? Okay, guys, the difference is where the energy is stored. If you're talking about electric potential, the energy is stored within the electric field. All right, so energy resides inside the electric field. That's what it means. All right, so you don't need to have a charge. This region is already energized. That's what it means. Energy is within that region. It's stored within the electric field of that region. In the case of the electrical potential energy, it's stored in the charge. All right, so here the energy is already inside the field. That's time voltage for potential. We're going to add on to the electric potential, the definition of it shortly, but just go with this simplistic definition. So what's the difference between potential and potential energy? Potential and potential energy is related to, difference is related to where the energy is stored. In the case of potential, energy is stored in the electric field. In the event of potential energy, it's stored within the charge. That's it. One last comment before we got one more minute. Okay, so how's potential related to the strength of the electric field? I think that's fairly straightforward. Stronger the electric field is, more energy is going to be stored in. All right, so they will be directly related. So stronger the electric field is, more energy is going to be stored in it. All right, so stronger the electric field, more energy is going to be stored in that region, and vice versa. All right, 7:30. Take a break for 10. Okay, so how's potential related to the strength of the electric field? Can be directly related to it. All right, so potential related to the separation distance. Once again, you got this direct relationship anyway. So the larger the separation distance is, the more energy is going to be stored in it. So the question is why? So larger the potential, the larger the separation distance is, the more energy is stored in it. All right, so the question is why? I don't want to have a discussion regarding this because the concepts are a little bit too new in your minds, in your heads right now. So we gotta kind of take time on that one. Okay, so I don't want to rush that. Okay, so let's get back to PowerPoint. We have enough right now that we can play with. So let's play with what we already know. Okay, let's just play with this briefly. I'm not sure if this is the right moment to discuss something like that, but if not, we'll come back to it tomorrow or next week. Okay, guys, positive charge, bring the positive charge near a positive charge plate. Okay, so what happens to the amount of work that you do on this positive charge in bringing this positive charge near a positive charge region? So you have to do work against the conservative force field, right? All right, so the amount of work that you do against the conservative force field is going to go into the potential energy of this charge. All right, now this charge has potential energy. As soon as you release it, what happens to the potential energy? Because the electrostatic force is a conservative force field, it's going to get converted into the kinetic energy of that charge. Okay. Whenever you bring a positive charge near a positive charge plate, a region in this case, does the path of motion matter? Yes or no? If you're dealing with a conservative force field, that's the nice thing about the concept. The path of motion does not matter. The only thing you have to worry about is the initial and the final points of this path of motion. All right, so the amount of work that you do against the conservative force field is going to go into the potential energy of the charge. Okay, so why do we have a negative sign up front? Okay, the formula that I'm interested in is this one. Okay, this is the one that you should remember from Physics 1. What is the meaning of this formula? When you guys see this formula, what does it mean to you guys? All right, that's what I'm interested in. These formulas are representations of these facts that I've been just mumbling about forever. So W equals negative delta U equals delta K. So what does that mean? Why do we have a negative sign in front of this? Any ideas? Okay. You guys have been using this formula forever without realizing or understanding the meaning of it. All right, so work equals negative delta U equals delta K. All right, so what is that supposed to mean? What that means is really, really easy. In terms of gravity, here's what you're looking at, guys. When I drop this, what happens to this potential energy?
Decreases.
Decreases, right? What happens to this kinetic energy?
It decreases.
Okay, notice that potential energy goes down, the kinetic energy goes up, only when there's a conservative force acting, right? So what's missing here is when the work is done by a conservative force, what's happening is the potential energy decreases. That's the reason why you have a negative here, and the kinetic energy increases. That's what it means. Okay, it's a powerful statement. It's very important that you understand the concepts first, and then the formulas are usually summary statements of what we are discussing. All right, so ideas are expressed in the form of math, but the math tells you the same thing. So when there is a conservative force field, like gravity or the electrostatic force, when they take over, what they do is they reduce the potential energy and they increase the kinetic energy. That's what it means. All right, so it's a simple statement. So what does a conservative force do? Conservative force reduces the potential energy and then increases the kinetic energy. So when there's a conservative force acting, the potential energy is going to decrease. So the charges will move from a high potential energy towards the low potential energy region. All right, so when I let this charge go, what happens? This is high potential energy, right? So it's going to move from high potential energy towards the low potential energy region. It goes from high potential energy region to a low potential energy region. So that's what a conservative force. That's what it means. Okay, so let's enjoy back and forth. Let's get back. Well, did I just mention that when you let a charge go, when a conservative force field takes over, it's going to take the charge from a high potential energy region to a low potential energy region? Okay, so that's what I said. Okay, now, I'm going to make a statement. I'm going to keep making the same statement every 10 minutes or so. Eventually, it's going to sink in. And then I'm going to give you a stupidly simple explanation for it that you will remember for a long time. All right, so what is potential energy that the charge has? Yeah, right. Potential is the amount of energy stored within this region. You place a charge in it, now the charge has potential energy, right? Potential is the amount of energy stored within a region, which has electric field in it. All right, so this is potential. Energy is going to be stored within the electric field in between two regions of opposite charges. That's it. All right, so the energy is going to be stored within the electric field. And then when you drop a charge in it, now the charge has potential energy. All right, that's what I was saying. So I'm going to just give you a little bit more sophisticated definition of it. All right, I'm going to isolate potential. So the potential becomes the amount of energy stored within the electric field per charge. All of a sudden. Do you get it? All right, so the potential is the amount of energy stored. Oh my God. So the potential is the amount of energy stored within the electric field per charge. Okay, so what that means is, and this is important, this volts is the same as the joules of energy stored per coulomb of charge.